Thank you all, and welcome to this session called Double Trouble, a new perspective on AL. And welcome to Tech Days 2024. It's really great to be here. I was afraid a little bit, Luke has decided to split up groups. Like Waldo and I usually draw a big crowd, and then Luke has a problem. How does he put everybody in the same room? So we split up Waldo and me this year. So we're now competing for the audience. And I was pretty sure everybody would be there. But it's really cool to see all of you here. Thank you for coming. I hope I'm going to deliver an interesting presentation for you. I will just shortly introduce myself for those who don't know me. My name is Vjekoslav Babić, or Vjeko. I come from Croatia. I've been an MVP for too long now. I don't know if Microsoft shares that opinion. We will see in a month when they announce the extensions. I've been talking a lot about AL. I've been involved a lot with AL. And recently, I have started really worrying about writing testable code, good code. It became more and more important. I come from backgrounds such as C# and TypeScript. I've done far more C# and TypeScript in my career than AL. And for me, in those languages, testability is the wrong term. Testing, unit testing, is a no-brainer. You just do it. And in AL, it's always kind of a problem. Like, we really don't test. Let me see who tests here. You may clap your hands or show. Yeah, very few of you, really. Like, okay, some hands went up for you who are listening this on YouTube. That is the reality. We don't test. And why don't we test? We will see a little bit about that, but it's not easy. That's the bottom line. We don't test because we become inefficient. And for me, it started becoming a big problem in AL, so I took on a journey to actually try to see how can we make it better. And here I'm going to share my learnings, share my experience, share my thoughts, give you some perspective on testing. And in particular, I'm going to talk about test doubles. And just one other disclaimer. I have talked about test doubles a lot, like a year and a half ago, give or take. I know I delivered a 1-hour session on Areopa. Anybody listened to that one? Let me see. Few of you, yeah, okay. So this is not a repeat of that. This is a completely different story. Also, I've been speaking at Days of Knowledge 4 times this year, actually. Anybody was there? Yes. Also, that's not the same talk. I also talked about test doubles and testing using test doubles. This is a story that you could talk about, or I could at least, for far more than one session. I could talk for a week. It is a never-ending story. So that said, let me just go deep into it. This is going to be a deep dive, but I will not do coding. Like I really don't have demos. I have code to show to you. I will not run anything. So everything that happens will happen just on screen. Before I start, I would just like to introduce this thing, which you may know as the testing pyramid. Is anybody familiar with the testing pyramid? There is some theory behind this. Like, it explains how we should test our code. Like, at the bottom, the foundation of this pyramid is unit tests. We should have a lot of them. The size of each block tells you how many of each of these you should have, like how important they are. The bigger the block, the more tests you have, the more focus you have there. So unit tests, as you can see, are sitting at the bottom of this pyramid. They are essentially, the pyramid says they are the most important. And then on top of that, we can build upon, like we could do integration tests, which obviously we have less of them. And then we go up, and we could call them whatever we want. Like, there are different kinds of things that live on top of integration tests. Some will call it end-to-end tests. Some will say, some will divide it into system tests, UI tests, acceptance tests. I don't know what kind of tests, any kind of tests. And like these manual tests, they still happen. They just sit on top. And then funny thing with this pyramid is that, as you climb this pyramid, certain things happen. And for example, execution time increases. Tests are slower the higher up you are. Like, it takes far more time to run a manual test against any feature than an automated test. It's a no-brainer. And essentially, unit tests are fast, integration tests are slower, and then system tests may be slower, and then on the top we have these. Also reliability. Like, unit tests, they're reliable. Also integration tests are reliable. Less so, as you will see. But manual tests, how reliable are really? Like, how far can you trust your people that they have really tested everything every single time? Then efficiency and cost related to that efficiency. Unit tests are cheap to run. And integration tests are cheap to run, but manual tests are very expensive to run. And then they cost a lot, especially the error that they create costs a lot because we find out about that very late. So this is this pyramid in theory. But in practice, our realities, and not just in AL, look a lot more like this. Far more teams just have those people who say like, testing is not my job. Anybody here ever heard that? Yeah, just a few of you, good. I want to work with you then. You know, like people just say like, yeah, I'm a developer, I'm not a tester. That's somebody else's job. And then companies often say like, but who will pay for that anyway? Like, who will pay for me writing these tests? Let's not waste time there. And customers definitely shouldn't be paying for that. It's not, I mean, it's our manufacturing cost. When I buy a car, I want the manufacturer to do the crash test for me. I don't want to do it myself. Thanks to Marco for this, like, I'm always using this. And then, you know, like, we all give an honest attempt. I know that every company who explored unit testing or testing in general, they have honestly tried. And then, you know, you get those brittle tests, anything you touch, the same test fails again and again and again, time after time. And then you just comment it out to take it like it, so that it doesn't stand in your way, so you can move on. Anybody experience that? Yes, of course you have. So, and then, you know, consultants are in charge of testing against PRs. Like you're a developer, you don't test, of course. So you push your PR, and some consultant will now take it, test it. And you know, consultants have their own pipelines, you know, like they talk to customers, they handle documentation, whatnot. It will take a while until they process their pipeline. So it is really a messy situation. And I don't really have a way out of it other than just say like, okay, let's retry from the start and let's see why this has happened. And I would really like to take this thing out of this dumpster and talk about unit tests today. This is the topic of this session, unit tests. So what are unit tests? Let's talk about unit tests. The funny thing about unit tests is you cannot just start. You cannot just say, okay, good. Let me sit here in my AL development environment and I will just start testing the crap out of my solution. You cannot. Let's see why. So what are unit tests? First of all, they are granular. They attack smallest possible units, typically functions, but also code units. It all depends on your structure and goals. But as granular as you can get, that's the better approach. Also, they are isolated. What does that mean? Like, anybody ever wanted to test a warehouse shipment process? I had. And then when you want to want to test that, yes, you need a sales header, but for that you need a customer. And you also need to post a journal. So a lot of stuff happens. The test becomes slow. Setting it up becomes tedious. Isolation means you want to test warehouse shipment in isolation of everything else. You don't need to go there. You just test this thing. So that's isolation. We will see how we can isolate the system under test. System under test, by the way, is a name for whichever unit we are testing with a particular test. We will see how we can isolate them. And then unit tests really try to be comprehensive. They aim at 100% testability, coverage. But 100% is, I mean, you never reach that, and you shouldn't aim for that, really. But unit tests are not interested in covering every single line of code. They are interested in covering certain lines of code and skipping others. And making this distinction between the two is important. And then when you do that distinction, when you separate peripheral code from critical code, unit tests will want to cover 100% of critical code and 0% of peripheral code. And it's achievable. And then they have to be repeatable, just like every test, something that doesn't hold true for, manual tests. Like same time, same results. And if something changes in your code base, the test should theoretically fail, because if it's a breaking change for the test could fail. Or if you change test could fail. There are only two reasons why a working test may now suddenly fail. Only two reasons. First one is you change the code base. Second one is you change the test. And we know far well that in AL, very frequently there is a third reason. Data changes, right? Anybody runs Microsoft's base apps suites locally? constantly. Microsoft, please put your hands down. So we don't, because they are unreliable. We don't have their setup. There are 37,000 plus tests, 15,000 of which, 15% of which fail if you just install it on like a fresh container. Because we don't use the same setup. They have specifically set up their database for testing, and they run their pipelines against that setup. But for us, it doesn't work. That shouldn't happen. That's not repeatable. Unit tests should never do that. And then frequent. Like integration tests, we are familiar with them. Like I'm pretty sure a lot of you do integration testing. And we run them in pipelines. Like you push a pull request, and then some pipeline will pick it up and run some tests, and then either all up, thumbs down, but tests run there. That's integration tests. Unit tests, we, developers, run them constantly, like 50 times per hour if necessary, on our local machines, which means that they have to be darn fast. And if you ask me how fast, well, if your test suite, unit test suite, takes longer than 10 seconds, you have a problem. And that's achievable. Like, I usually demonstrate like some of my test suites, like one of my favorites. It doesn't have that many tests, like around 250 tests, maybe 300 now. And that runs in under half a second. So that is achievable when you test with unit testing approach. So we will see how we can get there as well. I will not really focus on performance. I just want to emphasize how important it is and why. It's not random that I want my unit test to run fast. I want this instant feedback. I know that when I change a line of code, if I broke something, I want to know it now, not in a week, not in a month. Because now I know what I changed, I can fix it immediately. But the later I figure out what caused my test to break, the bigger the problem I have. So this is what unit tests are. And here is an example. This is a system under test for my real-life project, where obviously I'm doing something with Stripe, I'm creating a customer, and then I'm testing if this works. This is the, actually, this is not a unit test, this is the code that I'm testing, and I want to test this path. Essentially, I want to see if creating the customer fails, I want to see this error. A legitimate task or goal for unit test. You want to test every path. So here's my test. Like, as you can see, like this test looks a lot different than tests we are familiar with. For one, actually, sorry, why has this happened? Yeah, sorry, yeah, I want to show another. Yeah, this, I want to show you how I test this path. Yeah, sorry. So this path actually, like now I want to see what happens if creating customer succeeds. So I have this version of the test. And if you pay attention to what is happening in the test and the code, you can see, for example, I have no givens here. I just have this semi-cryptic factory implement something. And then I'm totally unconcerned with setting up sales invoice header, which is something that you would have like 3-4 givens against if you're doing the typical traditional kind of test. And then if you take a look at this here, like I want to control, I want to send my execution down specific path. This is how I do it. This is how simple it is for me to say like, okay, go there. When somebody asks you, did you succeed? You say, true, I did. And then in the end, when I'm testing if this was great, I'm not doing like customer get whatever, whatnot. I just call this one. So this is what a unit test looks like. And then, like our experience with tests is that it takes a long time to write. Like you could say, okay, Vjeko, yes, this looks fancy, but yeah, it took you a while to come up with this. Actually, Luke always tells us, the speakers, don't do live coding. You'll mess up. But I decided to actually write a test like this. This is what my experience with writing tests looks like. So I want to write this case, and I'm here. I will just start with test. And then look at this. Copilot suggests this one. It sees that I am testing fails. Now it wants to check succeeds. So I do this, I accept this, and this is the correct test. Save, done. And I would leave it for a second. Yes, it takes just a little while until you get there. Like you need to write 2-3 tests. But if your mocking framework is in order, if it's transparent, not opaque, meaning readable, if your code is well structured, Copilot does this for you. And I'm not kidding. Like 60, 70% of my tests are written by Copilot and are correct on the first go. The other ones are suggested by Copilot, and I have maybe up to a minute or two work on them. If I don't have anything in my code unit, then I have like empty code unit. And I want to start testing. Yes, first test, maybe Copilot will struggle, but the second it will be better, and the third it will be better. Because I have very consistent naming of tests, very consistent flow, how I test, I tried to test Happy Path first, here I didn't. But I have this consistency, and Copilot catches on that. And then if I'm starting with something new, I do a trick, like I just start coding tests in an existing code unit, then when I have 3 or 4, cut that, paste into a new one, and again, I'm productive. Copilot is amazing. So it really gets the job done. I promised to myself I will not talk about Copilots because everybody does, but here we go. Like, it will write your tests for you. Why do we do unit tests? Well, obviously I want to verify that everything is in order. I want to know that all parts of the system work well together. I want to catch bugs when they happen immediately. I want to have instant feedback. And obviously I want to be able to refactor with confidence. How do you refactor if you don't have tests? How many of you refactor your code? Well, all hands should go up. We should all be refactoring all the time. Like, we need to clean up. Like, every time we touch something, we can probably do something to make it better. And I'm pretty sure we all have legacy code that we could improve. And without tests, that's a difficult task to do. So, I would like to talk a little bit about this. Like, something I never mentioned in my talks, because I was thinking, like, there is really no point in trying to present this angle. But here today, I decided to actually take this path. That's why this session is actually called Double Trouble. It's a double pun. It's a pun on test doubles, because test doubles is what the session is about. But there is also this fight between 2 schools of thought in testing. And that's why Double Trouble, because I will present you why these schools of thought are so different, and what is it that they are fighting against, or actually for. So they are called Detroit and London. Detroit, the guy actually over there on the right, it's actually on the left for you. Yeah, sorry. So that guy wants to test in a very specific way. And the school is called Detroit because of the automobile industry, because that school of thought drawed from their practices. Like, we want to do it like the car industry does that. And the left guy is obviously, right guy, is obviously called London. And that's because this school of thought has developed in London at some point. So let's take a look what is different between these two. Detroit style, also called classicist style, it uses real dependencies all the time. It focuses on testing state and verify outputs. And it will have very little emphasis on mocking. It doesn't truly care about that. It emphasizes realistic, integrated scenarios. That's what Detroit cares about. London, on the other hand, is called mockist. That guy will isolate everything, and you will always use mocks. He doesn't focus on output verification. He primarily focuses on interaction, collaboration. He wants to check or verify behavior, and he will heavily use doubles. And as I said, like, he emphasizes collaboration between components. That's the most important thing for that guy, to see how all of components collaborate together. And these come with trade-offs. None of these is better than the other. All of them come with some trade-offs that are important. For example, like Detroit, like, the big pro of the Detroit approach is that you will test realistic scenarios. Like, you will test, let's say, warehouse shipment, and it will go all full Monty, like all the way to adjust cost item entries if necessary. Because, yeah, you're testing the real thing. You have less mocking overhead. Like, you don't need to create mocks for anything. You just go and test. Tests are more stable. We will see why, actually. Why are tests more stable when we don't have mocks, or at least when we are not using mocks or properly? Then when mock tests become less stable, we will see about that. And then these tests kind of build higher confidence because you are using real things. You are testing the real stuff. You're not faking anything around, so you can trust those tests. On the other hand, those tests are slow. Mind you, all of our tests are actually Detroit style. Like, the entire Microsoft Base App test library or suite is London style. And we have learned to write London style tests. Now, the question is, are they really unit tests or not? That's also what these guys are fighting about. But technically, yes, they are, but also technically, no, they are not. But I don't want to really go there. So I will leave that up to you. What is good about London? Well, tests are blazing fast. Like all of those tests I mentioned, they're London. Like the tests I showed to you, they're London. And by the way, I'm 100% London guy. Like from here to there, like London full. Tests are isolated. Like I isolate everything, or actually London people isolate everything. This encourages good design, because what London forces you to think upfront is design. Because you don't write a single line of code without thinking, how will I test this? What consequences will this have on other aspects of the system? So this is in focus of London all the time. And then you have very detailed verification. London can reach 100% coverage easily. Without much effort, Copilot will get it there easily. But tests become very brittle. We will see about brittleness very soon. Also, there is maintenance overhead, since you are really concerned about what's happening inside of those tests, inside the system under test. You really are looking, you're covering every path. You're checking cyclomatic complexity to know how many minimum tests you want to create. So all of these are your consideration. There is a lot of overhead in there. And then those tests seem to be less realistic, because you're testing everything with mocks, like a mock here, mock there. So what is it that you're testing? I know that some of you here, after one of my sessions, are like, what is it that you're really doing here? Like, you're just shuffling around, juggling these mocks. Are you testing the real thing? Well, this is, it feels at least that we are not. And it becomes complex. The more you mock, the more complex it becomes. And this is actually, yeah, let's talk about why we need doubles. Like I mentioned mocks many times. I'm pretty sure, let me see, how many of you know what mocks are? Okay, not everybody, but a lot of you do. So let's see, why do we need test doubles? Let's start with this one. Like, it's an extremely easy function to test. Do you agree? Anybody who thinks it's difficult to test this function? Well, here are two tests. Like, I test all the paths through this very easily. I can verify that it works, whatever I send into it, and that's simple. But my question is, why is this easy to test? What is it that makes this function easy to test? No dependencies. Well, that's a good one, but actually something, it doesn't have to do with size at all. Like, size doesn't matter. You could have a one-line function which is extremely difficult to test, or 100-line one which is easy to test. What makes a function easy to test is this. Buzz is a pure function. It has no dependencies, essentially no hidden inputs, no side effects. Like, it doesn't change any external state outside of itself. It is deterministic. It will always produce the same output based on the same input. That's what a pure function is. It's very, very easy to test. That's what makes it easily testable. Nothing else. It is a pure function. But do this to it, and then my question to you, how do you test this? How do you test that? This is an impure function. It's non-deterministic because it has hidden inputs. You don't know what foo.bar will do. You have no clue. So how do you test for that? Well, we do test that. We are testing it all the time. So let's take a look. So the problem with this is that, first of all, side effects. I want to talk about side effects. Like, it may update the database, this foo.bar, or it may alter some global state in some single instance code unit. How do we test for that? Maybe yes, maybe no. But I do want to test for that. Also, maybe it calls a web service. Maybe I need to do something about it. Like it outputs depends on the web service call. So you have both the side effect and hidden input at the same time. Maybe it exports a file. So that's what side effect makes to testability. Like, it just makes it more difficult for you to test. And then hidden inputs, how does it compute its return value? You really need to look inside to figure that out. You are concerned with that. And then, depending on what happens in there, your tests can be, they can range from very simple like this. Maybe, this is a typical example. Like, I read some setup and then do some logic and go out, and then my test will have like 2 givens, and that's easy. But it could be difficult. Like, maybe I read a couple of fields, then read some more tables, and then I start shoveling up givens on this heap, and it becomes difficult to test. Or it could be, extremely difficult. Like, here you can say, yeah, you're overdoing it. Yes, I am, intentionally. Like, this is not a real scenario. This is an example. But I've seen tests with 52 givens. You will see them too. They exist in Microsoft's test suite for base app. That's the biggest one. The next biggest is 32 givens. And then you go down. And I guarantee to you, you have the same situation, and it's just inevitable. If your foo bars do this, then you will have to have those givens. And yes, libraries help to an extent, and Microsoft has done a tremendous job helping us with that, because we can use their libraries to set up those givens easily and quickly, and maybe we could compress 5 of them in one call, and then, yeah, we don't have to care. But those givens are still there. And then, what is funniest here, sometimes it can be outright impossible. Yes, I forgot to say that. This is something that you cannot control. So you will not be able to test this function at all. But let's go back to this one. I have a very important question to ask. How, if you look at this, this is the flow. I go from here to there, and then I set up all of these givens. So this tightly coupled code has deep testability consequences. Because every time I want to test something which is tightly coupled to something else, I need to look into that something else to figure out what is going on. And, it is a task, really, I give it a name. Remember, we want to test this function. That's the function we want to test. I'm asking you a question. How are these given for that? When you look at the code, you don't see that. You don't see that, and you should see that. You should see, when you say given for a test, you should see why is it given for this test. And here we don't see that. I call this chasing givens. Have you been there? You start writing tests for that, darned warehouse shipment. And you need a sales order. But you need a customer and a posting group and an account and then another account. And you need an item with the posting group and some more accounts and an inventory posting setup and a location. Oh my God. Well, yes, I'm exaggerating, but this is essentially a very, very big problem. And then the tests like this, they are often fragile. What does it mean for a test to be fragile? It means that it can start changing its outcome based on stuff not in the system of the test, nor the test itself. A fragile test is a test which can fail due to environmental constraints, like database changes, like some setup somewhere changes or some record somewhere changes, and tests start failing. We've all been there. That's fragile tests. Don't mix them up with brittle tests. Brittle tests are those tests which will start failing for smallest changes in the code base. Like you change some small thing and suddenly, boom, 5 tests fail, or 1. That's what brittle tests are. They are not resilient to changes. You keep changing stuff, and yes, tests just start failing. And essentially, this is where most of the teams just give up on testing. That's my experience. I've seen it in the practice. You just give up because it takes so much time to chase all those givens. And then it takes so much time to try to stabilize those tests. And then you just give up. So go back to this. How do we test this then? What do we do? There must be a way. Well, there is a premise that always holds true about code. The code on the left, this function, bus. It must not care what foobar does. It should not care. There is only one thing that this function cares about. Do you see what that is? The Boolean output value. Buzz receives a Boolean output and makes a decision based on that output. That's all that Buzz needs to know about foobar. So, if this premise always holds true, then we need to do something to bar, or foobar. We need to decouple it. So let's see what decoupling is. Well, the first step is we need to take the interface out. In languages such as C#, you do control dot, extract interface, and boom, you get an interface outside of a class. I am dreaming maybe having that sometimes in AL, like control dot, extract interface. Okay, David Feldhoff is coughing, is nodding to me from the first row. He did this code actions. Obviously, I didn't check this one, but Okay, agent, okay, good. But okay, we have that. So you extract the interface. What does it do? It takes all of your public procedures or methods or functions, whatever you want to call them, and creates an interface object for that, which describes how foo works. And the second step, obviously, you implement the interface on this foo. And then, if we look at Buzz, at this moment, Buzz is concerned with this bar, right? Like it really depends tightly on it. It's tightly coupled to bar. If you change bar, you need to change Buzz. And then, if we just do this small thing, like we move this declaration from local variables, being a code unit, a concrete, into parameters, which come into this function as an interface, as an abstract, then we can stop being concerned with the concrete and we can start being concerned with an abstract. And you could say, yes, this is now breaking change because you're pushing responsibility upstream. Now all of your callers don't compile anymore. Thank you for breaking this for me, Vjeko. Yeah, nice job. But it's so easy to fix. You just do an overload. It's an illusion. It's not a breaking change. This overload that you add, what does it do? Well, it calls the same function with the same old tightly coupled dependency, which means that, yes, it's no breaking change, like we can now keep calling this Buzz function with old parameter set, with the old input against the old signature. And that overload will pass, or actually involve, exact same object in execution at runtime. So there is no breaking change, not logical, not compile time. Problem solved. Good. So now we have this. What now? What do we do with this? Like, cool, we have an interface. Let's take a look. Let's now start talking about test doubles. How do we use test doubles? There are a number of test doubles. We usually say mocks. And I would really like to talk a little bit about each of them. I would like to say what they are, why we have them, and how we may want to use them. And I will give code examples as I go. So first one is called dummy. And essentially it's a placeholder. It doesn't do anything at all. We just use it when we need to pass a dependency into some function, So we will use a dummy. We will just use an object that does nothing. You will see code examples soon. Then we have a little bit more complicated one. We call it a stub. A stub provides predefined answers to questions. Like, for example, you have seen two stubs already. Like you have seen, or actually you have just seen one. Like in my code written by Copilot, Copilot has essentially used the stub. So it has said, when somebody asks you, did you create a customer, just say you did. And then stub answers with that question. And then we have spies. Spies record interactions, like how many times you were called, were you called, with which parameters were you called. So spies are there to tell us how the components interact. We will use stubs to control the flow, like to make decisions or to send code down specific paths. Spies will be used to tell us if something happened and how did it happen. This is very important for a London guy, as you will see. And then fakes. Fakes are working implementations which are not suitable for production. For example, in C# or TypeScript or Java, you have those frameworks. Like in C# you have NUnit. In Java you have JUnit. In TypeScript you have like Mocha, Jest, I don't know, whatnot. And those frameworks typically have mocks for everything. Like you could just mock a database. In TypeScript, you just say, I need a mock for database, you get a mock for database. And it's actually a fake, which fakes everything. Like your application sees that as a real database, as a real thing. Everything it does happens as if it was a real database. It's just a fake one. It's holding everything in memory for efficiency purposes. Typically, we do that for efficiency purposes. We don't really have much opportunities to create that in AL, because our language does not have that power on that level. We could fake fakes, make them explicit, inject them as dependencies, but that is tedious. So I would not really, I tried, like in many of my sessions, I tried to present a real fake, and I just gave up on that. Like we don't really have true fakes in AL. They're essentially, or typically, just statics. And then you have mocks. Mocks are combined stubs and spies. That's the simplest description. They're more than that. They will more often than not contain built-in assertions, like they will fail under certain conditions. Like they try to behave like real-time objects which expect specific things, which you can configure and do funny things with them. And we will see exactly what they look like. I will start with dummies. So let's take a look at this interface. We have extracted it from our class, or sorry, code unit. And now we want to make a double for it. We want to create a dummy. This is the dummy. As I said, it does nothing. It's not even concerned with returning any value. Why? Because we know we will never involve that in anything. Like this object just sits there. So the question is, why am I using it at all? Why am I defining an object that does nothing, that will never be called? What's the point? Well, this is the point. Imagine that I have this function now, which I do, because I've refactored it. So this function cannot be called without this foo interface. And if I only care about testing this path, as you can see, foo bar will not be hit in that path. Like I'm setting up the test to skip around that. Like I'm passing a value which will never hit bar. But my function still needs bar as a parameter. So I pass a dummy because, yeah, I don't need to do anything with it. That's a dummy. Let's take a look at the stub. Same code example. So we have the same function we want to test, and then we define a stub. What good does it do? Well, if we want to test this path, like, okay, we enter inside here, and then we want to see what happens if foobar says true, or what happens if foobar says false. Actually, yeah, I forgot. I thought I had a false. Apparently, I skipped over that. So essentially, you just say to this foo in this test, you say set result. So when somebody asks you, you respond with true. And then you see, did everything happen, what should happen when you send it down that path. So essentially, you're just doing very simple assertion there. That's a stub. And then a spy. Sometimes the only thing you care about, because you have covered everything else, you care about knowing if a specific dependency, or in this case we would call it a collaborator, was involved during the execution. So on the left side we have some code which does involve a collaborator. And maybe I just care to know if this collaborator was involved. So I could just call the function, and then I just assert that, no, if these are conditions under which this function is called, this collaborator must not be involved. And then spy will tell me. And then if it was involved, my assertion fails, and I know there is a bug in my code because somebody has suddenly called this method which shouldn't be called under these conditions. So my spy helps me prove that path or that truth about my code. And finally, we have mock. As I said, mock is just a combination of, like in simplest terms, it can be very complicated, but in simplest terms, mock is just a combination of a spy and a stub. Essentially, you can use mock instead of spies and stubs just to, control the flow by setting responses to questions that will be asked from your collaborators. Also, you could spy on your collaborators. You could see if they were involved, how they were involved, which parameters, etc. You could expect, for example, just like I do here, like I expect it to be called with specific parameter. If I do, then when I call something, if specific value was not passed into it, I fail, which means my test fails. So I can assert that collaboration is not just happening, but is happening in the right way. So mocks will do all of those things. Mocks are essentially the most comprehensive of objects. And now one question that I often get asked is, do you really create all of those dummies and spies and stubs? Like, would I really end up having 4 different objects for this thing here? And the answer is no. Why? Why would I? The names are not concrete names like you need an object called dummy or you need an object called spy, and if you need both a dummy and a spy, then you will create 2. No, this is about roles that they fulfill. It's important for you and for everybody who writes unit tests to understand what is the role of my collaborator And then you know, okay, I'm collaborating, like I want to control the flow. Then it's a stub if you want to control the flow. And then I want to see if collaboration happened and how it happened. Then you know it's a spy that will do that. Or if I just need an object in there, but I will not involve it at all, then it's a dummy. So mocks can fulfill all of those purposes. So typically people just use this term mocks. And most of people who do testing or know about testing in theory, they know about mocks, or at least they have heard about mocks. So this is what mocks are, the most comprehensive name for all of these types of doubles, which we will involve in different roles in our test. So don't go and create 50 different objects just because you have 10 different code units to test, and then you need all of them. Like for each one, you need all 5 types. No, there is no need to do that. And then some frameworks, like, as I said, like Jest, for example, that I'm using to test Object Ninja. That framework just has on-demand mocks, like, anybody using Ninja here? Yeah, okay, thank you. So I test really quite a lot of Ninja's backend, because that's the most critical part of it. And then backend is in Azure. Everything that happens in Azure Blob. And then how I test that, I obviously don't write to Azure Blob when I'm testing. I am mocking Azure Blob. So I just say to Jest, give me mock for this class. And it gives me mock. And then my code sees that mock as a real class. It talks to that mock as if it would talk to a real class. And then I can check, like, essentially all of those methods I've shown to you plus more are present on all mocks created on demand. And I have a dream that at some point we may have something like this in AL. Like, you don't need to go there and define your explicit mocks yourself. You essentially just say mock interface or mock code unit or mock table, just like we have test pages. What are test pages, people? They're mocks. They're mocks for our pages. So maybe at some point I am hopefully looking at Microsoft here and hoping for this. I'm not sure, but Microsoft does care about testability. Like this keyword that has just happened, and that I think I will show. I think I have a screenshot with this keyword. It's something that aids in writing unit tests and a lot more. So Microsoft does care. Maybe they realize this would be a nice thing to do. So these two guys again. Let's now talk and try to see like how they feel about mocks and doubles. So when would these people mock? The Detroit guy will say, no, I will never mock. Really, I will mock if absolutely necessary. Let's say I'm talking to an external web service, I will mock that. Or I'm talking to a piece of hardware, I will mock that. But preferably never I will mock anything. Whereas the London guy, that guy will say, oh, I will mock everything, like whenever possibly, preferably always. And obviously, you can see that these two are not compatible. There's a lot of conflict that comes out from this. And I want to, even though I'm a London guy, like I totally believe in London approach. And by the way, when I'm talking about, let's say, TypeScript or C#, I'm a Detroit guy. Why am I London in AL? Because in AL, we often don't have much choice. Like London has these difficult obstacles that it puts in front of us, and we will keep seeing them as we go. But I still believe that in AL, at least with the state of affairs as we have, London is the best approach. But I still think that mocks are necessary evil. I don't mock because I love to mock and because I really enjoy that, or because I can. Because some London people will just mock because, yeah, just for the sake of mocking. Here we go, Detroit here. See, this is how I do it. So that's not why I mock. I mock because I have to. When I have exhausted all possibilities, I'll mock. But if I can do it without a mock, I will try. So let's take a look at this, like a real overkill that I've seen, and I've been there myself. Like I've been learning. Like I'm sharing my learning experience with you. So I had attempts and tries and you know. And maybe when you see this, you will think, okay, but this is so simple. Why didn't you see it up like immediately? Well, maybe I'm not as smart, but let's take a look at this. Like we have this function here. And it's a typical AL function. Like it does something, shuffles fields left and right, then does some database insert, and done. And in ugly AL function, it would be a part of a very big function, probably somewhere in a loop, inside of another loop, inside of a case, inside of an if, inside of another case. But if you're doing a good job, then you would delegate that work into a function of its own. And then the question is, how do you test that? Well, here we go. Here's a test that legitimately tests this function. So what do? Obviously, I need to set up a vendor for this. I don't see a way how would you be able to run a test without doing this. But it's simple. I don't need to write that vendor to the database. And then I call this create customer. I pass this vendor and I pass this number. Let's not discuss the logic of this. Like, why am I passing number into this? Why am I not using number series? Simply because I want to have a simple example, nothing else. So I'm passing this number, and then, since I know which number it was, I read the customer from the database, and then I do some assertions, and if all true, then I'm happy. Essentially, my test has passed, and I know that my code works. And here, there are some problems. Essentially, and we will see that as well, database is my biggest problem here. Like, why don't I like accessing database from my tests? Does anybody have any idea? Yeah? Slow. Well, it's not that slow. Come on, we're 2024. Like, it's slow. Yes, it is slow. Like, we are talking milliseconds, but milliseconds is exactly what you cannot spare because they accumulate. Guess what? They do. Especially the more Detroit you go, the more tightly coupled your code is. I've seen tests running for half a minute. I've seen tests running for 5 minutes. Microsoft doesn't have those. But I have seen those tests. And why are they slow? Because of accumulated effect of database operations. So if I can avoid writing to database in my tests, I will avoid. What is so slow about writing to database? Well, first of all, you need to write to the database, obviously. Then you need to read from the database to assert stuff. And then when you're done with the test, you need to roll back the data that you wrote. So 3 database operations just to validate a simple function like this. And then imagine that maybe I had to insert a vendor, and maybe I needed to call a number series for this, and maybe some more things. Suddenly, this test moves from 2 milliseconds to 15 milliseconds. And then maybe some more database operations, some more invocations to something. Suddenly, it's, 300 milliseconds. You know what average time to run a test is? And I'm referring to Microsoft's library because that's, the biggest one I could see, like the biggest one I could really, do some comparison against. 700 milliseconds. That's average time it takes to run a test. There are 37,000 tests. Microsoft runs them every day, multiple times. They do it in parallel. So they parallelize, like they distribute that work. They probably have more hardware for that than fits in this room, I don't know. But they optimize that. But still, this needs to be done. We cannot afford all that Azure for our tests. We don't have that, freedom. So for us, most of test suites I've seen are not parallelized. They're all serially running tests. And then you will start feeling those effects. And that's why I don't want to touch database for my tests, if I can avoid that. So I want to, with this unit test here, on the right side, over there, you can see that I have really tested this function. I know that this function works, so all is hunky-dory, I can move on. Let me move on. I'm moving on. I have a function which calls this function, which I also need to test, right? Because there is legitimate code inside there. And I now want to test if foo works. When I call foo, will it do everything that it needs to do? And, to test foo, I will call customer from. And I know that customer from works. So I will hit it again, and it's slow, and I will hit it again. And you know what? Detroit guy says, so what? Hey, where's the problem? Just do it. Go on. And London guy oh, it's a waste of time. I need to do something about it. So London guy goes and says, okay, let's create an interface called Overkill. Let's implement this interface on this code unit. And then let's, inject this as a dependency into this class. And now I can test it like this. I can mock it. I can, spy on it. I can fake it. I can do whatever. So, and London guy is now happy. But, I mean, just take a look. There must be a better way. And my question to you is, where does this end? The moment you start doing this, and I was doing this, it has profound consequences on the shape of your code base. You can imagine that. Like if you start doing this all over. It costs. Yes, your tests are blazing fast. You wouldn't believe how fast they are. You cannot measure that, how fast they are. We're talking microseconds. But I pay with the shape of my code. So let's try to apply a little bit of Detroit philosophy here. Like this function is impure. It has side effects. It modifies the database. And the Detroit guy says, so what? Let me learn from him. Let me say, so what, too. But there is something I can do to make this not my concern. I said this is an impure function. Is there a way to make it a pure function? Well, not really. Like I could split it up into two functions. I was doing that as well. Like there is a blog post, I think it's the last one on my blog, where I'm doing exactly that and I'm proposing that. And back then I believed that's the way. It's not. I will really have to go back and, yeah. But, you know, I'm not afraid to say I was wrong because I was. Like, that's not the best way. Yeah, it is a way. You can do it if you want, but it doesn't make your code look better. It just makes your tests run faster, nothing else. And eventually, maybe it starts hurting you. It never hurt me beyond, come on, Vjeko, look at all these functions that do nothing, just database insert. Just so I can test that assignment works as an isolated function. That's just because, I hate impure functions, so I try to get rid of them. But you cannot get rid of impure functions. AL is impure. You cannot do anything to it. Like, it's a language which it's not a functional language. Functional languages care about purity, like F# or, I don't know, ADA or Lisp or I don't know, whichever. But AL shouldn't truly care that much. Yes, it's better that function is pure than impure. But if you cannot do it, if you cannot make it pure, don't sweat it. Keep it as is. So how can we make it a little less impure? Well, we pass a parameter by reference, this var customer, into it. And instead of having this customer as a local, tightly coupled, we inject it. Just like we inject a dependency of interface type. Dependency injection works on everything. Like every time we pass a parameter, we are injecting something into a function, essentially dependency. So we pass this customer into it. Yes, technically speaking, at least if you talk to a F# person, they will tell you, yeah, this is still impure. You're modifying your input parameter. That's not allowed. That's impure. And I agree, that is impure. But it's far less impure than touching the database. Because tests, you now can test this easily. You just pass, as you can see, like a temporary customer into it. So you can test the same function, passing temporary variable by reference, and you do get. It happens in memory. Guess what? There's your fake database. We have an implicit fake. Huh, what do you know? So we can do something with this now. If we know that we can pass this customer by reference, we could propagate it all the way. So we pass it by reference to foo. So that when we call foo, we can not just run this code, we can now also observe this. This is what London wants. London wants to know what happened to this customer. And if we don't do anything, we will never be able to. And we don't need a mock for that either. And London will be happy here. So we really can see everything that happened on this. And then, in the end, this is our code. We could add another overload. I've mentioned it already. So we don't break anything for existing callers. This overload does everything as it did before. I will call it peripheral because I don't care about testing it. That's not critical code. Critical code is this full signature foo. And I will test this full signature foo Detroit style. It will call another function and I don't care. Because I can still observe everything that happened. I don't need to spy. I don't need to do anything funky with any interfaces. As I said, database is a big side effect. And we cannot really get rid of it, and we should not. Like, it's impossible to completely isolate yourself from database in AL. There are tricks like this, and it is not really a trick. Like, I think it's a good design principle. So just use dependency injection. So if you collaborate with the customer record, and you do, you should use it as a dependency. And why am I saying this? Like, imagine that we didn't have a record type. Just imagine for a second, like, give me that there is no record type in AL. That we really talk to the database using some interfaces, just like we do in C#. Then I wouldn't be passing record variable into a function. I would be passing an interface variable or a class that implements that interface. So what's the difference? Like, that's dependency injection for me. Why doesn't, like, this database stuff is a collaborator of this function. If I'm writing to database, which means calling database API, which is exactly what record insert is, that's database API. If I'm collaborating with, that's my dependency, I need to inject it as a parameter. So it is a good design thing, not bad. And if it hurts you, like if you cannot propagate that all the way up, then just add an overload where you will break things, and everybody will be happy. So that is not a trick. That's a legitimate way how you can improve your code and testability at the same time by applying a good principle called dependency inversion through dependency injection pattern. As I said, in other languages like C#, you just say, like, I need a fake for my SQL, or I need a fake for my ADO. In AL, we cannot do that. But what we can is just do dependency injection with database. Pass records by reference where we touch database. If we do find set, pass it by reference, and then you will be able to test with a temporary set of data. If you collaborate with two records, pass both of them by reference. And then break it at some point where you think it's dangerous, and everything is going to be fine. So it has profound effect on testability and zero effect on runtime. So, as you can see, like, a little bit of redesign can really go a long way. And now let's consider this. Like, let's take a look at this function. Like a simple code unit with 3 functions. One of them is global. One of them is local, or 2 of them are local. So what am I trying to do here? Like, it doesn't really matter, but I have this simple call where something will happen that doesn't cost much in terms of runtime resources. And then I will call another function, which will do some heavy lifting, which will, I don't know what, first call a web service, then call a database somewhere to read whatever, then pass it back to me. I will do like this much of code against it, then call something else. And it becomes very, very difficult to test that. So what can I do? Like, look at this. Like, Detroit says, well, again, where's the problem? Just test it. That's your code. Write your test. Be a man for a while. And London will say, oh my God, what do I do? Like, I totally must mock something here. I need to take it apart. So it's a big problem for London approach. And let's take a look at what will London guy do. So London guy will create this foo controller. And this foo controller defines this method, whatever it's pronounced. I asked ChatGPT, give me those foo bar. That's how far I knew. And then he spat out like 50 others which are reused around. So this QX something. So I isolate that into an interface because that's my heavy collaborator. And now I can mock that. See? Like, I can mock it. Like, I can just call bar, passing this mock foo into it, and I don't worry about this inefficient collaborator. And since the only thing I probably care about in this test is to know if that collaborator executed, because there is no decision against it, it's not involved inside of any loop, there are no decisions outside of it, so it's a very straightforward test. Very easy for me to test. And London guy is happy now. But this is a problem. Do you see the problem? Well, it's written there, but did you see it before it was written? I had to change the signature. It's no local anymore. This QUX is now an internal function. How do you like that? Yeah. It's bad. Like, Detroit goes crazy about this. And London is, he kind of, he's happy for 2 reasons. Why is he happy? First of all, he wants to isolate that because it costs. It costs in terms of runtime performance during testing. It will slow down his tests. Let's say this is the function that causes the test to run for 5 minutes. So obviously the London guy does not want that. He wants to just skim over that. So that's the first concern. He wants to just, control it. He wants to mock it. And the other one is, since, there is some bulky code in there, obviously, because it takes 5 minutes to execute. London guy wants to test it in isolation. He wants to call this function. Detroit guy, he will tell QUX through testing bar. He will just call bar, and it will test everything, full Monty. And London guy wants to test every unit individually. And this is where they clash. Essentially, this is where every team suffers. Like, every team I talked to, every environment I was in, I was talking about this. Eventually this happened. This type of a discussion. What do you do with that? And not just in AL. I remember a C# conference where there was a topic on this, like, how do we handle this problem? Because you have the same. Like, let's just shift our minds a little bit. I believe there are people here who understand what C# does, for example. So in C#, imagine you have a class, and then you have a public method and 3 private methods. How do you test those privates if they're heavy? Well, the same problem is here. Like, you cannot access them from your tests because your tests are, they are hidden from tests. So what do you do there? And there are approaches like interface approach. You create an interface for tests, and then you implement that interface explicitly on that class, and then you talk to that interface through this explicit implementation just from your tests. Nobody else will see that, just you will see that, because only you know about that interface, because it exists in another DLL. Complicated. Or another approach, like you go and you create a derivative class, like you mark the method virtual, and you create a descendant class which overrides that method. And then this class is something, it's essentially a subclass that you will call from your tests, but nobody else will be able to call it. Also, like a little bit less complicated, but also an approach. But this is always a problem. Like, there is always fights around this because it has very, very, very deep consequences on everything in the system. There is no easy solution. So let's imagine, like, what are our options really? What can we do? Well, first option that you have is that you go and you keep your locals. Like, you just keep them local. Detroit guy is happy. Obviously, like, why wouldn't he be happy? Like, that's how he tests. He doesn't really care about, something that Detroit guy will never do is change the code for the sake of tests. That doesn't happen. Why would you? Like, you have code. There are reasons why the code is like this. If you want to change code, you should change it for reasons outside of the tests. Like, for reasons inherent to the code. Is the design bad? Redesign it. But Detroit guy doesn't say, like, hey, tests will tell me when my designs are bad. But London guy says, yeah, that's why I test. Like, I want to improve my design. So I will see while testing the design is bad, and then I will improve on it. So any local function, in this case, London guy wants to test them directly because they are inefficient. So London guy will say, let's just, open them up. Let's just, turn them internal. And this really makes Detroit guy just give up. Like, he quits the job and goes out of the company. He doesn't want to spend any more time there. And there is another option, which is kind of a compromise. And this is to decompose the whole object. Like, you just take this heavy function, move it completely out in another function, or actually another code unit, and then wrap this code unit, or actually extract the interface, and then use it as a collaborator in here. And then, London guy is happy because, yes, he can test that directly. He can fake it when it's used as a collaborator. Detroit is kind of, okay, well, I kind of could settle to this because, it's not inside of this object, so technically it's not a local that I'm accessing. But again, there is this local functionality now, which used to be local, probably for a reason. Nobody should be calling that, which now exists as a non-local. Like, still everybody can access that. And when you do that, like, you do this decomposition and delegation and all, your complexity goes up. And it's the same everywhere. It's not an AL issue. It happens everywhere. And here I will actually show you a demo. So I wanted to structure this entire session around this demo, but then I gave up. So I realized it could be too complex. I will share the examples. I will definitely blog at some point about this. Now I will have a lot of time that all of the events are over. I was really busy with Days of Knowledge and Tech Days now. But let's take a look at this. Like, what I wanted to present to you is this refactoring of resource journal posting. Something that I don't particularly like about the design of posting in AL, in the base app, is because there is like so much repetition. Like, every posting routine has journals, which consists of templates and batches and lines, and then you have documents which have headers and lines, and then you have a check line and a post line and a post batch and post yes, no, whatever. But it's always like you go to item journal, you go to inventory journal, you go to FA journal, you go to intercompany whatever journal, I don't know what. It's always the same. Like, it's the same design, and code is copied over and over and over, and structure is the same. Like, last year for one of the events, I wanted to present a fake posting routine. So I developed I pulled something out of, I won't say where, and developed some demo against a posting routine. What was I doing? Like, for half a day I was copying and pasting. Like, I was looking at base app, trying to find the simplest one, so I have the least amount of work, because I'm lazy. So I think it was fixed, no, not fixed asset. It could be intercompany, some journal, whatever. But it's the same, like, it does the same check line, it does the same loop through lines, filtered by batch, whatever. And the problem that I see with that is that it happens all over. Like, if you want to create a new area, you will have to copy and paste all of that. And I have a feeling this could be, and I don't expect, this is not a critique. There are reasons why this is like this, but in my, London view, it would be so much better that we just have one routine for posting journals, and then we just pass dependencies into it and whatever. So I started with this resource journal. I never get too far, but what I want to show to you is the effect of extreme London. Like, what happens if you let a London happy guy like me into your code base? What does that guy do to it? And I'm not 100% sure this is good. So, but I just want you to see what happens when you try to mock the bejesus out of something. So I started here with this post line, and essentially, as you can see, this post line now implements like every interface out there and their sister. So obviously I have created those interfaces. And I will start here with this on run. And I will do run with check, and then this run with check calls another overload with run with check. And I'm not really sure why I did that. Now I don't remember anymore. Yeah, of course, because I'm passing this. I promised you will see this. So I'm passing myself as a collaborator into myself, so that I can mock myself when I test myself. But I mean, it sounds funny, but I will run tests against this. So I will find some test references. Actually, no, because I didn't write tests for this one yet, but you will see others. So let's go on. I have this one, which will be hit by on run. That's when you run the journal posting routine. And then I have this one, which I will hit by tests. Like, I will never call this, because this just uses tight coupling to itself. It essentially passes itself to this one, which receives itself as a reference, and it receives a reference of controller type. So what the heck is the controller type? Well, there are things that happen in every journal, like you check line. Then well, obviously this is too concrete. As I said, like, I didn't get too far. I just wanted to create a demo, nothing more than that. So it's check this, like post the line, then it has this code function, which I should rename, because code is a very bad name for functions. I can understand why functions 5,000 lines long back in 1973 didn't have better name, but these days we should really be calling code better. And then so this is my controller, essentially some interface which explains what happens to a journal during this posting process. And then I can progress through that like this. Like I say, controller get GL setup, so I can mock database access. I wouldn't do it that way today. I did it 3 months ago. So, and then I will call this run with check on the controller. So I get in here, and then I need to find which one is that. So there is some of these which will respond to that. And then essentially, yeah, this is this one. And then here I have this original line. I copy that and essentially call this post journal, which is another step in the controller. And it's obviously implemented on myself here. And maybe I think I can check, I can find this one in tests. Let me see. Where are my tests? Well, I have quite a bunch of them, but I think something is wrong with reference counting. Whatever. You will get the code, you'll be able to play with it. And then, I again call this controller, and I pass some more stuff, like another controller I get in here, and then I check something else. Then I process this journal, and this one is funny, like because it does this, like workflow. What the heck is workflow? Workflow is another interface, and this interface, like, does stuff. I mean, at some point in this work, I realized, okay, this is obviously not the way. I need to not show this demo. So I prepared a better demo, which I'm not showing to you today because I really want to finish that one. And I'm really proud of that one because, as I said, like, I'm also learning here. I'm just sharing my learning journey with you. And I want to show to you, like, when you become too happy about this London approach, it can get really bad. Like, my first step here, and I will show you that step, like essentially when I have refactored my resource journal line, I will just go in here. That one is actually good because I have nicely refactored this code unit which had essentially one big function, and then when you look at this, you can really see what's going on. Like, it follows this single responsibility principle all over. Like, I have functions which are testable directly if I care to test. They're all local, but yeah, Detroit guy doesn't care. That's where my London guy kicked in, and then I did that abomination which I just showed. So, but essentially this is just a bunch of smaller functions, and it looks nice. I'm happy with how this looks, because if I really had a way to properly test that, I could. And then I found some other approach to this, and I am going to complete this example because I really want to show that this is possible to do in a really clean way, not this convoluted way which will have consequences. So this is something that happens when you try to mock everything. It also doesn't work. So Detroit people have some point in there. This complexity that I've introduced here, it leads to one thing called brittleness. I've mentioned it already, and I will mention it again. And this really kind of looks like a big problem, and it very often is a big problem for teams. So what is brittleness? Brittleness is, again, when you have tests so tightly coupled to your code. Because how does London work? Let's think of that. Like, London cares about one thing called cyclomatic complexity, because cyclomatic complexity tells London guy minimum number of tests he needs to write to know that he has covered absolutely every path through a function. So it's a tool which helps. And then London guy will try to cover every path. So we'll just really look at every if, every case in there, and we'll try to do something about it. Mock it, fake it, control it in a way. And then his tests, essentially, well, they explain so well what is going on in your code, because when you look at tests, you really see, oh, I see now why this is like this. Those tests tell you everything. But you change one line, you change one condition, you rearrange lines, suddenly tests fail, because tests are so tightly coupled to the logic that they test that they cannot survive this change. And this is a problem. It causes friction in development process, because the more time you spend on fixing failing tests, the less productive you are with doing stuff that you should really be doing, which is writing code. And when tests are brittle, minimal changes will very often break a couple of tests. And especially when you are about to do big refactoring, you may need to just throw all the tests out and rewrite them all from scratch, if they are written in that way. And now funny thing happens. Like, Detroit guy goes, oh my God, I told you, you will have a problem. There, see? I told you. But London guy says, so what? So what? I want it to happen. When Detroit guy has brittle tests in mind, this is what he has in mind. Because if this breaks, oh my God, yes, I really don't want to be that guy to fix this. Because this can break who knows where, deep down. Like you touch something in journal posting and suddenly warehouse posting fails. And you need to figure that out. And you don't know right away because you cannot afford to run that test because it's slow. So your pipeline tells you that it's failing 2 weeks later. And you don't have a clue what broke that test. So you spend 3 days fixing that, chasing more givens or whatnot. And London's brittle test looks like this. And the London guy says, well, there was something here. I don't know what happened with the bullets, but I will tell them. So what does London say about this? London guy says, well, that's the idea. That's why I wrote my test to look like this. I expect them to fail. Because if I'm testing a piece of code and something changes in that piece of code, I want my test to fail. That's the goal of them. Where's the problem? I will have this test done in 15 seconds anyway. I will just kill the old one, Copilot will complete the new one, and everybody's happy. Where's the problem? So this is this different perspective these two guys have on things. What is problem for one is good for another, and vice versa. It's always trade-offs. And what do you know? I managed to finish a session in time, which didn't happen in I don't know how many years, the Tech Days. So let's try to wrap this up. Unit testing should be a foundation of absolutely every testing strategy. You cannot properly say that you're doing good development work if you're not trying at least to do unit testing. And then, as you have seen, this tightly coupled code, where code always uses concretes, where you cannot do anything but propagate from high-level calls all the way to low-level calls, and you have no way of controlling that, you will suffer from some kind of a problem. Either you will have a big performance issue if you are doing Detroit-style tests, or you will have issues with mocking, with structure, and like visibility of your methods if you're a London-style guy. And obviously, you cannot just start unit testing. You now can see that. You can see why you cannot just go and say, yeah, let me just start writing unit tests. You cannot. You need to do something to your code base. You need to start making it testable. You need to take active steps on that. And test doubles can really help. They're a good tool. They really get the job done when used properly. And these two styles that exist, which I wanted to present in this session, essentially I wanted the session to revolve around that. They are both valid. They're both correct approaches. You cannot say that, Detroit style is wrong, or Detroit people cannot say London style is wrong. They will keep fighting and keep fighting. But both are valid. Both have cons, both have pros. And I hope you have seen them now. Like maybe you understand those trade-offs better. You have learned from my experience, so you don't have to fall in that trap. Because I've tried to share everything I've learned while I was on this journey. And then something that you can always try to do is you can try to strike a balance between these two, because as I said, both are valid. And you can combine them. You don't need to be, on a crusade for London or a crusade on Detroit. Just learn from what's good in each of those approaches. And as you have seen, like with that database example, sometimes you can just learn. If you're a London person, you can just learn from Detroit. Like just structure a code, like do just smallest change, and suddenly this tight coupling becomes less of a problem. You can control that to an extent here and there. And then please start unit testing. You will be glad. Like it will be difficult in the beginning, but in the end it always pays off. Thank you very much. So, thank you. Thank you. Q&A time. We have 9 minutes. Yes. By the way, sorry. I will bring you the microphone, and first 4 people get a T-shirt. So, who needs bugs when you have Copilot? Yeah. You have one? No? Well, here's your Copilot. Hello.
Yes. What was the question? So I was just wondering, when you say do unit tests, and you have now shared your experience and you collect a lot of experience, still for me it would be where to start. Is it like there's this saying about bite the elephant in pieces? So should I start with something small? Should I start with something big?
Well,
sitting on a really old code base. So we also have functions like code.
Yeah, but well, we all do.
Yes.
There is no simple answer to this question. But I can tell you how I did it in AL. Because I had a lot of testing experience from the past, and I was this Detroit guy who always said, so what? Because you don't suffer from performance in C# when you're doing Detroit, unless you're really doing something funny, in which case you will mock still. I was always mocking, just not that deep as I'm doing it in AL now. But my AL journey was like this. Like I was hit by a problem, like the typical situation that all of you have certainly been in, that you are trying to change something and it keeps breaking, like you never get it done. You always, like, you fix one feature, something else breaks. And I was just sick of it. And I said, like, okay, like my tests are brittle, they serve no purpose. I'm constantly commenting them out and on and off, and kind of always hoping now this test might work, uncomment, then fails again. Comment, do something. So what I did is I said, okay, I'm now taking this code unit, which was really badly written. I inherited it, just like, you know, Microsoft has inherited this entire base app. You know, they have the same problem. Like, I know for a fact that they want to solve that somehow. So every team I've seen in AL has inherited some code, because developers who wrote it probably aren't there anymore. So what my solution here was, there is this abomination of a code unit, which I inherited, which I need to do something about because it's my problem now. I just said, I'm going to start unit testing that. And then I started writing it from scratch. And really, I did TDD. Okay, this function, start with test, write function, test, and then it grew. And in the end, I was happy. Like, I ended up suddenly, like, before you know it, you have hundreds of tests. You can go on, and suddenly it works. It's nice. So essentially, you will find a feature, and then you will start refactoring, or maybe just rewriting it. But I cannot tell you anything else, because it's a like, I cannot tell you just go throw everything out the window, or just go there and refactor everything in one go. Like, for example, I mentioned Microsoft. Like, Microsoft suffers from, like, they also don't like the fact that they're testing their suite with tests that run for 7 hours if you run them in sequence. They want to improve that. But what I can guarantee, I don't know because I'm not Microsoft, but I can guarantee that they will not just say, okay, now all hands on deck, let's just refactor everything, so next release is just tests and code which was full. That's not gonna happen. Not there, not in Microsoft, not in my team, not in your team, not anywhere. So you will actually have to start small, like pick an object, just maybe pick an object, any object, maybe the least important one, and then just try with your team. Let's try to unit test this, then refactor it, then get it better, and then start from there. That's all I can say, really. Like, there is no recipe.
Thank you.
You're welcome. Okay, so Peter, but then pass the microphone over there, and you're done.
Hi. When you change the parameters for a function to...
Sorry. I cannot hear you because I'm down here.
Hello. If you're changing a function to include an interface as a parameter, you say, okay, does it work? Yeah.
I think it does.
You say, okay, something else will fail, it will break, so you just make an overload, and then everything will work again. But isn't in fact that also postponing the inevitable? Because at some point you probably want to change the other functions as well, isn't it?
I don't.
Or do you want to leave them?
I don't think it's postponing the inevitable. Like, you all have this trade-off. Like, I'm changing a signature of a function. And then if it's a critical function that's being called from 55 different places, then I will probably just put an overload in there. And I don't see a problem with that, because then all of those functions, all of those places that depend on this thing, they will just keep working. And I will still be able to test that. But if I have 2 places where I call it from, and it doesn't hurt to refactor both of them, then I will refactor both of them. So my first approach will not be like by default. I will not create the overload by default. I'm just saying that if you need a solution, that's the best one. But eventually I will have a lot of overloads. Like in this code I showed to you, like this resource journal attempt at posting, that's full of overloads. And then, yes, it becomes difficult to read that code. Like, it's all clean, all like follows good structure, like functions are really single responsibility, concerns separated, but so much, you know, functions that have one line of code and code the next function, which calls the next one. So, yeah, it's a trade-off. So I say, like, don't just create overloads if it doesn't cost much. If it's a breaking change for your third parties, like we are talking app in app source, that you expect customers to PTE bejesus out of, then yes, then you will probably want to put an overload in there for next release and then probably refactor when you have time or something like that. So, yeah.
Thanks.
Microphone over there.
Thank you.
You're welcome.
I just wanted to ask, how are you feeling about test-driven development? Because it didn't really sound like...
I love it.
Okay.
Yes. So I cannot say that I always do it, and I definitely don't do it the way how Ken Beck says, like, go there, write a failing case first. That's just too extreme for me. But I do it. I love it. Like, because it's funny, like this is also my answer to the question, who pays for tests? I pay for tests. That's my manufacturing costs. But I am more productive. My productivity doesn't suffer because I always have this confidence that everything is in order. So try that. Like it does work. So again, like I sometimes find myself that I've gone for a day without writing anything in my tests. But that is very much of an exception. Like it's mostly like I end up having like 20, 30 tests every day. And you know, it starts paying off pretty soon. Like at the beginning, it looks kind of pointless. What does this one test do? One and one and one. Suddenly you have, before you know, you have a lot of them, and then you just feel so confident about your code. So try it. Yeah.
Thank you.
You're welcome. Who was first? Okay.
Thank you. I was wondering...
I think I have one more shirt to give, so...
Okay. Yeah, I was wondering, what do you consider to be the correct approach to the tests architecture-wise? Like, would it be a separate... would it be a separate app with a dependency?
App.
Yeah, okay,
it must be a separate app.
Yeah, we've been wondering that.
Like my demos, and I always say that I didn't say that to them today because I wasn't showing any demos, but my demos always have tests in the same app just because it's so much easier to just press F5 once rather than pressing it 4 times, which you need to do when you're developing both tests and the app, because then app breaks tests, so you need to like first publish fails, then you publish second time, then tests. So that's why I put them in one app when I'm demoing, but for real life, you need to have them separate, absolutely.
Yeah, okay,
like
great.
Separate.
That's
one thing that please don't do, that's also something I approach in my extreme London journey, is like create an app that describes testability interfaces that you then depend from your app and test app. And then only you see those interfaces and nobody else sees those interfaces. That's a wrong approach. Don't do that. So architecture-wise, 2 apps. App, test app, done.
Yeah, thank you.
Yep. Over here.
Yeah, I was wondering about, well, this goes a bit over this session, but I was with the Waldo's workshop about the performance testing.
Yeah.
How would you start doing performance testing? Would you use the London or?
I don't know. You would need to talk to Waldo. Like, I'm not concerned much about performance testing, and I don't think that these principles apply to that.
Yeah, that's what
I think these principles apply really to unit testing and maybe to an extent to integration testing, but I don't think how they would apply to anything above that.
Okay.
Like system tests, acceptance tests, you just do full Monty there, like it's Detroit all over. But I really don't know, like performance tests, they probably have their own Londons and Detroits that fight their own battles and crusades. Yeah.
Yeah, because when you have some givens when you do the performance testing, then what if something changes with the customer? You change a posting group or something, then it all goes boom.
Yeah, well, I know, but again, like I don't know, like this, I wasn't focusing on that. Like it's totally not in my focus at this time. So I really don't know how to tell you what would be the best with performance tests.
Maybe next time.
Maybe next year, I don't know. Like, we still have 20 seconds left. Anybody wants to say how good this was? Yeah, this is how much time.
A little bit off topic, but does your team use the page scripting tool for acceptance testing of any kind?
Again, like, no, we are not there. Like, we are focused on unit tests right now. Like, I'm involved in a big project where we're doing like big unit testing implementation. That's the goal, unit testability of everything.
Agreed.
Page scripting tool, that's something that has recently appeared. Honestly, I didn't even look into it myself, because from my angle, I don't need it, because that's so way up the pyramid. That for me, I don't see how I could take any advantage from it. But the people who need it, and I cannot tell you who this is in this community or maybe at this conference that you could talk to, but I'm pretty sure they are here.
Okay.
They could tell you much more about that, because it is a useful tool, but just way up there, up the pyramid somewhere.
Yep. Thanks.
Okay, so this is going to be, once I almost killed the person, so let's try to survive. Everybody? Okay.
Yeah, I guess as many people here, we can have like a decades-old product. So my question would be, how would you start to calculate how much time it would require to make this decades-old code base testable? Like we have to refactor, we have to write the codes. How should I sell this work to my manager?
This is a software estimation question. How do you estimate effort in development? I will share with you a tweaked formula, which I just came up on the spot that I learned from a community guy back in Croatia back in the day. How do you estimate in software? You take your first educated guess, then you multiply it by 2 and take it to the next unit of measure. So if you feel like 3 hours, it is more like 6 days. And if it's like 2 months, it's more like 4 years. And I would say with an effort like this, I would do something like maybe ×3 or ×4 instead. So yeah, I don't have an answer to that, obviously. It is a massive effort every time you try to do it. I haven't seen a project or a team where it was just easy. Yeah, please, yeah, it's you who I was talking about, so. But he can share his experience with me, yeah. So, thanks, Sigi from LS. Yeah. Well, thank you very much, people.
Yeah.
Enjoy the rest of the conference and see you around. Yeah.